In this example, we're going to still use the same strategy that we had before. Let whatever's in your parentheses be your u. But in this case, remember some of the rules that we established earlier on. When you have a radical, or when you have a variable in the denominator, usually if you have a especially radical, you need to see all your exponents, and you do not see all your exponents if you have a radical. So remember, exponents, fractional exponents in particular, are radicals. So this third cubic root square is a fractional exponent. So remember what you learned in pre-calc. Roots grow in the ground, they're down in the ground, denominator. So that's how I always remember, where does that 3 go? So that 3 is going to be the denominator of the fractional exponent. So I'm not doing y prime yet, I'm still rewriting y so I can find y prime. So 4x squared plus 3x minus 2 to the 2/3. Denominator, down in the ground, roots, root. That square stays as the exponent. So technically, if I hid that denominator, it's still to the second power, right? So you just have to make sure that the root is the denominator. Now you see your parentheses, that's your u. So u is 4x squared plus 3x minus 2. U prime, or du dx, is 8x plus 3. That's your first and second step. Third step, rewrite your y. So I would say this is like my little side thought, because I'm going to refer back and forth to that. Y is u to the 2/3, or just u to the 2/3. We don't need those parentheses there. Next step, take the derivative of y with respect to u, dy du. 2/3 u, take away 1 from 2/3. When you take away 1 from 2/3, that's minusing a 3/3. 2 minus 3 is -1. If you have a hard time with fractions, it's time for you to conquer that. Either do what I just did here, or do that, check it on your calculator. So you do 2/3 minus 1, and then you press math 1, and it shows you that you're going to get -1/3. Now, did I forget something? I did. It's got to be the derivative of y with respect to u, dy over du, times du dx, or y prime. So now, to finish this, you now substitute your u's back in. So you get 2/3, your u is 4x squared plus 3x minus 2 to the -1/3 power, and your u prime, put that in parentheses, please put everything in parentheses. That 8x plus 3 goes in parentheses. This is still a little messy, and depending on the answer keys in the textbook ask you for it, you should always try to put the coefficient with something that doesn't have an exponent, because then they can be combined and brought together. Negative exponents usually get brought down to the denominator, and that's a root, so it's a cubic root. So you can also think of this as y prime is 8x plus 3. Let's put the 2 in front. So 2 all over 3, so it's 2/3. And then this drops down to the denominator, and it's a cubic root. So it's the cubic root of 4x squared plus 3x minus 2. It's to the 1 power, right, because of that 1 there. But this is a more concise answer, but we're beginning, right? So if you get to here, this is good. Eventually start to realize how you can manipulate terms to make them look differently. And be comfortable with saying them a bunch of different ways, because at different times, different answers are more appropriate than others. But this is your y prime. Now, this same example went a little bit further, and it asks for you to find dy dx, or y prime, when x was -2. So you can look at either of these and substitute in the -2, but the final answer here, it would have been better if you substituted the -2 into that, just because you have to look at the -2 to the -1/3 power, but you could evaluate it there as well. It's really not something that you should put too much stress too much over. Just substitute the -2 in. So if we substitute the -2 into this version here, you're going to get 2 times -2 times 8 is -16 plus 3 all over 3 times the cubic root 4 times -2 squared. -2 squared is 4, positive 4. 4 times 4 is 16. 3 times negative 2 is negative 6 minus 2. This becomes 2 times negative 13 all over 3 times the cubic root of 8. Cubic root of 8, 2. So y prime is equal to 2 times negative 13 all over 3 times 2. So your answer is negative 13 over 3. Now remember, the derivative at an x value is the slope of the tangent line to the curve at that x value. So negative 13 over 3 is the slope of the tangent line to the original equation, which was the cubic root of 4x squared plus 3x minus 2 squared at x is equal to negative 2. So this is your slope of the tangent line when x is equal to negative 2. So evaluating the expression brings you to that point of slopes of tangent lines.